All right, let's look at the homework 1.5, 1.6, problem number 15. All right, so you have this function, absolute value of 7 minus x over 7 minus x. We want to find the intervals where this function is continuous, right? So let's sketch this function here, right? So absolute value, so we have to actually split into two cases, right? First thing we should know is x cannot be 7, so it's got to be either greater than 7 or smaller than 7. So I'm going to do if x is less than 7, right? So if x is less than 7, which means that the 7 minus smaller than 7, which is positive, so absolute value sign doesn't do anything. So it's going to be 7 minus x divided by 7 minus x. But they cancel out, so which is going to give you positive 1, because we can cancel, right? We get that. Right? Then if fx is greater than 7, right? What happens is 7 minus something greater than 7 is always going to be negative. So absolute value sign, turn that into positive by negating it. So you're going to get the negative 7 minus x divided by 7 minus x, right? Then you can cancel 7 minus x on top and bottom. You're going to get 1 here. So with the negative sign. So this is actually negative 1. All right, so the graph is going to look like this. So here's the x-axis, and here's the y-axis. All right, then we have to split at x equals 7. So let's say this is x equals 7. All right, and this is going to be positive 1. This is going to be negative 1. All right, so if x is less than 7, it's going to have a value of 1. So the graph is going to be 1 all the way through up to 7. Then its function is not defined. We have to put an open circle there. And when x is greater than 7, it's negative 1. So we have a negative 1 here. All right. And so we're going to start from here, but it's an open circle. Then it's stay negative 1, right? So function is going to look like that. All right, then we should be able to answer questions right here. All right, so we want to describe the interval on which a function is continuous. And if you go back to the picture, you can see that it's continuous. There's no breakage less than 7. And above 7, but there's a problem at x equals 7. So we know that the interval that we are looking for would be from negative infinity to all the way to 7, but you're going to have to skip. So then I have to use a union, so set notation union. And then you go from 7 to positive infinity. All right, we got that. All right, then next question is identify any discontinuities. So discontinuity is going to be at 7 because we have a jump discontinuity there. All right, and then let's see, last question. If the function has any discontinuity, which it does, identify the condition of continuity that is not satisfied. All right, there's a discontinuity. F of c is not defined. F of 7 is not defined, so we have that. There's a discontinuity, of course, this is going to be violated. And the limit does not exist. You can see that the left-hand limit gives you positive 1, right-hand limit gives you negative 1. So the two-sided limit does not exist. All right, so I guess, except for the very last one, it says that there are no discontinuity, but there is a discontinuity. All right, let's check the answer. All right, I came back and looks like I messed up the last question. Let's see. So let's look at this. There is a discontinuity at C. All right, I don't know. Maybe I shouldn't have checked this one because you know, these two guys are. This is not defined. The limit doesn't exist. So maybe this is what they're looking for. Let's check. But it's not going to be satisfied anyway. All right, let's check the answer again. All right, I came back and it looks like we got the third part correctly as well. So since you know, f of c is not defined and you know, limit does not exist, I guess we don't even consider this one. So that's why we don't check it. But I don't know. In my opinion, I should have checked that one, right? But anyway, that's what the system wants. We know what it is. All right, that's it. I hope that this was clear.